And let's continue on functions and graphs. I'm going to move on to section 1.6. It's on the parent functions, right? A library of parent functions. And we have 8 type of parent functions. If you learn those, would be really helpful to draw other graphs. So first one, we're going to identify and graph the linear and the squaring function. And the second one, we'll learn how to identify and graph cubic square root and reciprocal functions. So identify the graph step and the other piecewise functions. And also recognize graphs of the parent functions. Again, we have 8 different parent functions. We'll get to each one of those. The first one is linear and the squaring functions. So linear function, typically we write f(x) equal to mx plus b. M is slope, b is y-intercept. Squaring function, f(x) equal to x squared. The graph of this is a parabola, opens upward, going over the origin. The graph of this is called parabola. Okay. And then let's get to the details. We try to recognize different type of functions here. So linear function f(x) equal to ax plus b, and typically we write it as f(x) equal to mx plus b for the convenience reason. Here m is slope and the y-intercept is 0b. Okay. And now let's take a look at the typical the domain, the range, the domain of the linear function is all real numbers. You can also say interval notation will be negative infinity to infinity. When the slope is not equal to 0, meaning it's either going up, or going down, the range of the function is all real numbers. Okay, so range is also all real numbers when the slope is not 0. When the slope is 0, then range is a constant. So it's b, basically. Okay, so range is also all real numbers, negative infinity to infinity. And the graph of the intercept of minus b over m. It'd be easy to solve it here, y equal mx plus b. I'll find the x-intercept for setting y equal to 0. If you solve for x, mx plus b equal to 0, then subtract b from both sides of the equation. Mx equal to negative b, okay, x equal to negative b over m. And that's how we get that. And the y-intercept is 0b. Okay. And the graph is increasing if the slope is greater than 0, it's decreasing when the slope is less than 0. So positive slope, increasing line. Negative slope, decreasing line. When slope equals 0, there's a constant line. 3 different categories. And let's look at this question. So we write a linear function f for which f1 equal to 3, f4 equal to 0. Here actually we are given 2 order pairs. This is x value. So first order pair is 1, 3. X value equal to 1, y equal to 3. Second order pair is 4, 0. So given 2 order pairs, you want to find out the equation of the linear function. Equation for a linear function. First of all, you find the slope. So you can label this x1, y1, x2, y2. Then we find slope first. Ym equal y2 minus y1 over x2 minus x1. Now throwing on the numbers, 0 minus 3 on top, and the bottom is 4 minus 1. So this turns out to be negative 3 over 3. And then find the quotient is negative 1. Now we know the slope, we just have to find out the y-intercept. So you can use the point slope formula or you can use slope-intercept formula. Here I'm using point slope formula since we know x1, y1. So point slope formula is y minus y1 equals slope times x minus x1. And we know the slope. Three things we know. Slope is -1, x1 is 1, y1 is 3. I'm going to throw into the equation, so y minus 3 equals slope, which is -1, times x minus 1. I will distribute it. Y minus 3 equal to -x plus 1. And I'm adding 3 from both sides of the equation. I will end up with y equal to -x plus 4. So we come up with the equation. This is not a function notation, so if you want to write a function notation, it will be f of x equal to -x plus 4. That's a function notation. Y is the same thing as f of x. Know that y is the same as f of x, just different notation. Okay. And this is what the graph look like. Y f of x -x plus 4. We know that slope is -1, so the y-intercept is 4. So we start with the y-intercept 4 here, and slope equal -1, -1, meaning down 1 unit, and go to the right 1 unit. Go down 1 unit, go to the right 1 unit. You get a second order pair, connected, extended. We get this line. And since slope is negative, slope is less than 0, so we know that this is decreasing line. It's going downward from left to right. Okay. And domain are real numbers, range are real numbers. We have a y-intercept, both x, y-intercept here. Yep, and it's decreasing line. That's a summary of this particular function here. Now, two special type of linear function. One of them is a constant function. The other one is identity function. So the constant function f of x equals c. Okay. So since it's a constant function, it doesn't go up or down. It remains flat. So f of x equal to c goes here. C could be any constant along the y-axis. Again, domain is all real numbers. Range is just the constant c. And infinity to infinity. Range is just going to be c. And the graph of constant function is horizontal line. And now let's take a look at identity function. F of x equal to x. Typically look like this. It goes going through the origin. Has slope of 1. So domain and range are real numbers. Domain are real numbers. Now infinity to infinity, range are all real numbers. And infinity to infinity, and it has both x, y intercept at a 0, 0, and then graph is increasing because slope is greater than 0. Okay, and that's what this look like. For the identity function, and identity function is very useful in terms of analyzing the inverse functions. Keep that in mind. Okay. Now let's take a look at the squaring function. F of x equal to x squared. As I mentioned, the graph is parabol, opens upward, and it's going over the origin, and also it has very interesting characteristics here. So domain is all real numbers. Okay, so domain is infinity to infinity using interval notation range. It's from 0 to infinity, including 0 to infinity. Okay, and the function is even function because it's symmetry with respect to the y-axis. Okay, I didn't draw a good graph. Let me modify a little bit. So actually, if you draw a perfect graph, which you could do easily in any like software or graphing calculator, it's kind of hard for me to draw a perfect graph here. As you can see, it's symmetric. It forms a mirror image based on the y-axis. Then we know that it's an even function. You can also quickly verify that. If you find out what is f of negative x, you will see f of negative x equal negative x parentheses square. That's also x squared. That indicates here f of x equal to f of negative x. That proves it's an even function. And the graph has the intercept at 0, 0. Yeah. And from negative infinity to 0 is decreasing. Okay, and then from 0 to infinity it's increasing. So that's a couple more things. Decreasing interval. And from decreasing to increasing, we have a absolute minima here. Decreasing interval from negative infinity to 0. Increasing interval from 0 to infinity. We do have absolute minima at 0, 0 at the origin. Absolute minimum. Decreasing all the way to the bottom of the valley, and then start to pick up from there. Decreasing on negative infinity to 0, increasing on 0 infinity, symmetrical with respect to y-axis. It's better graph here. Graph have relative minimum. Here is what we call the absolute. It's also absolute minimum here at 0, 0. And here below shows the graph of the square function. Very beautiful, smooth graph. Now let's go to the cubic function. F of x equal to x cubed. That's cubic function, square root function. F of x equal to radical x, square root of x. And reciprocal function, f of x equal to 1 over x. Okay, so those three, now three type of graphs. Let's start with the cubic function, f of x equal to x cubed. So domain of real numbers from negative infinity to infinity. Range, it's all real numbers, negative infinity to infinity. And the function is R function. Again, we can easily prove this by find out what is f of negative x. So it turned out to be negative x cubed. So this is negative x cubed, and x cubed is f of x. So this is f of negative f of x. That means f negative x equal negative f of x. And this tells us it's definitely an R function. And also the graph of intercept at 0, 0. And it's increasing on the entire interval from negative infinity to infinity. In symmetry with respect to the origin, 0, 0. And the graph looks like following. So from left to right, it's increasing all the way. You can see that it's going up all the way to the top. And let's take a look at the square root function. F of x equal to radical x. If you look at the graph here, as you can see, the domain should be from 0 to infinity. 0 to infinity. Okay. 0 to infinity, including 0. Okay. And the range it's also from 0 to infinity, including 0. And as you can see, this is increasing from 0 to infinity. Also has an intercept at 0, 0. Both xy intercept at 0, 0. And that's pretty much it about this square root function. And now the third one is reciprocal function, f of x equal to 1 over x. Now one more time, let's get to the graph. As you can see, the domain, it's all real numbers except 0 here. 0 just separating. Domain is all real numbers except 0, so it should be negative infinity to 0, union 0 to infinity. And the range, very similar to the domain, is everything except 0. You see this, so both x-axis and the y-axis are the horizontal to vertical asymptote. X-axis are the horizontal asymptote. For reciprocal function, and the y-axis is the vertical asymptote. Asymptote is a typical line or curve. The graph of function gets infinitely many close but never touches it, right? So we could get infinitely many close but never touches the asymptote. They're infinitely close, but never touches it. Okay. And let's imply definition of the asymptote. The range is all real numbers except 0, so it's from negative infinity to 0, union 0 to infinity. As you can see, it's decreasing. It's decreasing from negative infinity. It's decreasing on the entire, domain, basically from negative infinity to 0, and from 0 to infinity, it's also decreasing. Yep, and the symmetric with respect to the origin, we can also easily prove it's a function. So f negative x equal to 1 over negative x. So this is negative 1 over x. 1 over x is f of x, so this is negative f of x. Again, this tells us this is our function. So since it's our function, so it's symmetric with respect to the origin, and doesn't have any intercept. Okay, so our function symmetric with respect to the origin. And no xy intercept, no intercept. And that is the reciprocal function. Now let's move on to step functions and piecewise functions. Step functions also, you can also view that as a piecewise function. So step function, it's also called greatest integer function. It's denoted by this greatest integer sign of x. Okay, so f of x equal to the greatest integer less than or equal to x. Whatever number you put into the greatest integer sign, the number must be the greatest integer less than or equal to x. And for example, if you have greatest integer of negative 1, so the greatest integer which is less equal to negative 1 must be negative 1. Also, the greatest integer less equal to negative half must be negative 1 if you put it on the number line. So And this is 0, -1 is here, -half is here. And then the number which is greatest integer, which is less or equal to -half, must be -1. Okay. That's how you determine the value of the out of the greatest integer sign. And greatest integer of 1/10, if you look at it, 0 is right in the middle, and 1/10 is between 0 and 1. 1/10 must be here. As you can see, the greatest integer, which is less equal to 1/10, must be 0. That's why I like 0 here. So if you draw a number line, it's very easy to visualize this. Similarly, like greatest integer of 1.5. 1.5 is right in the middle of 1 and 2, and the greatest integer must be 1. Greatest integer less equal to 1.9 is also 1. And if you look at it, for greatest integer function, this is the graph of it. And the domain will be all the set of all real numbers, meaning all real numbers are possible. So domain is -infinity to infinity, all real numbers. But range, if you look at this, the range must be all those integers. So set of all integers. Okay. So if you want to list it, it will be -5, -4, all these integers, -3, -2, -1, 0, 1, 2, 3, 4, 5, and keep going on, right? Yes. You have infinitely many integers here available. The graph has y-intercept at 0, 0, x-intercept at 0, 1. Okay, we verify this. This is y-intercept, and then no, this is both x and y-intercept at 0, 0. The graph is constant between each pair of consecutive integers of x. And then you also jump vertically 1 unit at each integer value of x. So you jump up, it's like a stair, you're going to jump up 1 unit every time you move to the next piece. So it's like infinitely many pieces together. That's why it makes it so interesting. It's like putting together infinitely many piecewise function. Okay, so now let's look at this. F of x equal to greatest integer of x plus 1. So for greatest integer less equal to -1 must be -1. Okay, so we get -1 plus 1 give us 0. Right? Yeah. And second one, greatest integer less equal to 2 must be 2. So you get 2 plus 1 give us 3. And greatest integer less equal to 3.5. 3.5 is 1.5. 0, 1, 2, 3.5 is here. So greatest integer must be, which is smaller than 3.5 must be 1. Okay, so it's 1 plus 1 gives us 2. All right, so draw a number line. It definitely helps a lot to help you understand, and then get to the proper result. Okay. And this is how you draw the greatest integer plus 1. So you're shifting all these pieces 1 unit upward. Since we're adding 1 in the back, everything should 1 unit up from the parent function greatest integer of x. Now we have learned 8 different parent functions. First one is a constant function, identity function, absolute value function. Okay, so we didn't cover absolute value function too much. Let's look at the absolute value function. So for the absolute value function, the domain is all real numbers. All these x values are possible. The range is from 0 into infinity, including 0. It's 0 all the way to infinity here. all the way to the top. 0 origin. It also has both intercept, both x, y intercepts origin. And also it has symmetry line because it's even function, symmetry with respect to y-axis. So y-axis is a symmetry. Because it's even function. We can easily prove that f negative x here must be absolute value of negative x. So absolute value of negative x is absolute value of x, right? That's a key aspect of the absolute values function. And this is the same thing as f of x. Now we know that it's even function. Just verify that. And that's pretty much about absolute value function. And it's very interesting. If you look at the slope on the left, we have a function f of x equal negative x. On the right, we got function of x. You can also split the absolute value function into a piecewise function. So if you want to write absolute value function, it should be also written as it's negative x when x is less than equal to 0, and then it's x when x is greater than 0. So you can split it into a piecewise function for the absolute value function. And we also have the square root function. Okay. And we have a square function, cubic function, reciprocal function, and then also the greatest integer function. So you need to get familiar with all these 8 different type of functions and know what a graph look like. It will be beneficial, when we move on to later chapters. Okay, that's pretty much about this.